Thank you, and good morning, and welcome to the presentation of AT, Automation Technology. My name is Armin Jele. I'm responsible in Europe as a sales manager for key accounts and also for business development. And I'm more than 20 years in machine vision. So a lot of the time at Cognex, and also was working for a system integrator. So I know how to do complete projects. And at the end also for SmartWay. And all the time I was looking to AT, because AT has 3D sensors, which I need for projects and for customers in terms of more speed, of more field of view, more resolution, dual head, and so on. So since 1.5 years, I'm part of the AT team, and now I have it. So today we want to talk about new horizons in 3D imaging with warp speed. So warp speed really sounds like science fiction, but parts of that we already have, and the next is coming in the near future with our new C6 generation of 3D sensors. No? So a lot of questions which we had in the last minutes. So maybe I can give you some answers on that, and then we see what happens at the end of my session. First, I want to introduce a little bit AT. So AT, we are 50 people and located in Bad Oldesloe. This is in northern Germany, close to Hamburg. And we are developing, producing and selling special cameras in infrared and as well as in 3D area. So our 3D visions, today we talk about 3D. We have just cameras where you need a separate laser. We have the biggest portfolio of compact sensors. And if this is not flexible enough, we have our modular 3D sensors called MCS. I want to go in detail in the next slides. So also we have second division is infrared. There we have just cameras for streaming 3D images, but also we have smart cameras with a job and app concept, and you can do quite easily a complete turnkey solution. For example, for plastic welding, early fire detection, or hotspot finding on PCBs. And the third division is entity non-destructive testing with infrared. There we have turnkey solutions, for example, for dashboard check. So if you have any questions regarding infrared or some projects, don't hesitate to ask us. The best will be to send us an email and we'll come back to you. Today we talk about 3D technology, and first I want to mention some advantages and benefits which AT already have. So if you want to measure, if you want to do metrology with 3D, you need accuracy. For accuracy, you need resolution. Resolution means a lot of pixels, and we have the highest resolution up to 4096 pixels per profile. You see in right side our portfolio. So we have nearly 50 different standard sensors, compact sensors, and this multiplied by different laser options. So it's more than 200. So with that, you have a big range of field of view from 7 millimeter up to 1.8 meters. And really fast, at optimum, it's more than 200 kilohertz. No? Also, we have dual head sensors if you have some problems with occlusions and shadowing. This is the hardware. And most important is also our SDK and our algorithm. For example, the Multipeak, this is to handle reflections, or our high dynamic range. I want to mention multi-slope. This is really important if you have parts maybe with dark objects and also shiny objects. And if you have the exposure time to see the dark objects, the shiny objects will be overexposed. You have an overexposed laser line. And with this technology, we can avoid that the pixels are going in saturation. At the end, you get independent of surface, material, or color. You get really a good laser line. What does this mean? This is for you robustness. No? The sensors are really working robust. You get really good images and don't have to adjust a lot of parameters all the time. So, but we talk about laser triangulation, and laser for sure is a really important, but we don't want to talk about wavelength or color or different laser classes. I want to mention some special things like a laser depth of field. There were also some questions before. Here's one example, and one customer said, hey, you need on the complete set range, you need a very good standard deviation of the laser. So here is a chart coming from our calibration report, and then we can see and find the right laser with the best depth of field, and we choose this laser for this sensor for this application. Another thing, there was also a question regarding laser line thickness. So laser line thickness is important if you want to find some small defects, because the laser line must be 5 times smaller than the smallest defects. No? We can choose the right laser with the best thickness for the sensor. Also regarding laser focus or calibration, we always can choose the right laser for the application. Also in combination with our modular compact sensor, this MCS, we can find the best solution, the best sensors optimized for your application. So this is, we'll talk about our C5 series. Now I want to come to our C6, is the next generation with warp speed. So warp speed is the combination, and I want to go into details what we mean with that. The best is to explain it with our modular compact sensor MCS. So there are 3 modules. At least you need 2 modules, and one is a sensor module where I choose the imager, and the second is the laser module where I choose the laser. And depending on your specification, which you are insert in our MCS configurator, like field of view, working distance, triangulation, the rest is calculated automatically. Also, this link module in between could be without link module, could be small out of metal, and the bigger one are a carbon tube. At the end, you get really a customized 3D sensor, and this is without any additional engineering costs or minimum order quantity, and you get the optimized sensor for your application. So here's a screenshot out of our configurator. This shows the sensor module, how you can create it. And you see on the left top, first you choose the sensor. This means how many pixels you want, 1280, 2040, or the high resolution 1490. And then you insert the working distance, the size of the target, like width and height. And then the field of view is calculated automatically. You can choose a triangulation angle, depends on the application, from 15 to 45 degrees. You can choose a single head, or like here we have a dual head. You choose the laser color, and the rest, the details for the laser is for in the laser module. And you see exactly the results. You see the resolution in X, in Y, and also for Z range. And you also see direct the profile speed. In this case, there was a high resolution and still 3.5 kilohertz. And you also see the drawings exactly. You see the dimensions, you see near field, midfield, far field. And then you press a button, you press OK, and can get directly a PDF as a data sheet. So here I can explain what we have today. It's the C5 series, it's the first row, and the second row shows the C6 series. If we compare the 1490 HS, HS is for high speed, and if we compare C5 to C6, there is the same imager, means no difference, but the difference is with the new electronic, with the new FPGA. C6 is 2 times faster than the C5 series. This is one of the steps for our warp speed. Then you see here in gray the 3070. This is a new imager. This is really a new generation. This is developed by AT. It's produced for AT. This means, yes, for sure, it's exclusively. And this is really a special imager. No? And if you show normally, if there is a sensor with 3000 pixels by 2000 pixels, the imager is transferring all pixels 3000 by 2000 to the FPGA on the sensor. This means a lot of information. And then on the FPGA, maybe you can reduce the area of interest, and then this will be transferred to the PC. In this case, we have a pre-processing on the imager directly. This means we detect the laser line, and then only the pixels around of this laser line will be transferred to the FPGA. There is a setup, and maybe you can say you want to have 100 or 200 rows around of this laser line. But at the end, it's maybe 10 to 20 times less information which you transfer to the FPGA. Means also you're maybe 10 to 20 times faster. This is one part of the warp speed. And then you have a double speed of the FPGA. And then in combination with our new interface board, which will coming soon, we have an base T. This means 2.5 gigahertz per second instead of 1 gigahertz as it is today. And this interface, FPGA with the new sensor, that's what we call warp speed. And this is not only a small step of the evolution of the sensors, this is really a revolution. So this is the hardware. And for the hardware, we also need a new firmware for sure. And one important thing is the new GeniCam 3D or 3.0. It's a new, GigaVision driver. I guess everybody knows GeniCam. It's more or less a lot of years in the market, and it's coming from 2D. In 2D, you only have maybe an image, a grayscale image, which you have to transfer. And with GeniCam, you just can transfer 3 features at the same time. So with GeniCam 3D, we have the opportunity to transfer output of 10 different features at the same time. No? Maybe as you can see in 3D, we have a lot of different options. No? A range image, reflectance image, intensity, you have a point cloud, you have a scatter image, so much more information. And with GeniCam 3D, we have the opportunity transferred at the same time. Here's some examples. You have a PCB, we have a range map. At the same time, we have reflectance map. We transfer to PC and can get a combination of both. Another example, you can transfer a point cloud, 3D point cloud, with a reflectance map at the same time and get on the PC a colorized 3D point cloud. This is what we call multipart. Another really important new feature of the new software for C6 generation is a Multipeak. Here you can handle up to 4 different peaks. You can say maybe you want the first, the best, the single, the first peaks what you want to choose. No? And the peak means you get an image, you have the laser profile, and then you look to some columns. And if you find the laser line, you will get a peak. Ideal, it would be a Gaussian curve, but this is not in reality. So, and here's some applications, what you can do with the Multipeak. For example, there was also some questions regarding class. No? In this case, if you tilt the sensor a little bit, you get 2 reflections. 2 laser profiles means also 2 peaks. No? One of the top of the glass and one at the bottom of the glass. If you choose 2 peaks and measure the distance between the peaks, you can measure the thickness of the glass. And for sure, it depends on how you mount the laser. You can look through glass, you can measure the thickness of the glass, and also if you want to have the surface, maybe some scratches on the top of the glass, you also can inspect that. One example for Multipeak, another one is here for V-shaped welding. You have a metal part, and 1 peak and 1 reflection is what you want to measure, and you get a lot of disturbing reflection for sure. Now, and also, as you can see here, you have 2 peaks. No? What we can do with Multipeak, we can say, hey, we are just interested in peak number 0. This is the right one. And more or less, we ignore the peak number 1 because it's disturbing reflection, and we eliminate it. At the end, we get really a robust image with just this the right feature. So the new generation of hardware in combination with this firmware and with these features, and also, as I mentioned before, with this 4-peak algorithm to avoid reflections with the multi-slope to get good images on all material. We have the hardware and we have the algorithm to get really a robust solution, to get really robust images. And that is what we provide to our customers, to our partners. And our partners could be system integrators, value-added resellers, or OEMs or machine builder, which have experience in 3D and have their own vision department. And here I want to show you some examples, what they are doing with their own vision libraries or with third-party libraries. One example is from our partner SenseWork. It's an inline metrology. This means you want to measure 100% of the parts. And as you can see here, there are 4 MCS sensors of AT optimized in near field, far field, mid field. The depth of field of the lasers optimized. There are 2 laser colors. And at the end, you get with the software matrix SDK from Soft Agile, you get really a nice point cloud out of 4 sensors. This point cloud is compared to the CAD data. And you see here, the green flags means you compare the values. And if all values are in the tolerances, it will be green. So with this matrix SDK, you can also do quite simple multi-sensor calibration with these 4 sensors. And here on the top, you see, for example, you see the calibration part, what is used. So for the customer, they do now online inspection, online metrology application. Within 8 seconds, you can inspect one part and you do 100% control. And this is still C5 series. This means with C6 in the future, we can double the speed, minimum. Another example is from Spain, from our partner in Feynman with the measure builders and systems. This is, you see, inspecting of metal parts. The robot is putting the parts on the conveyor. And we have here four 4K sensors. And you see also the sensors are going up and down because the sensors always in the right focus and the right distance. And also in future, there will be a new MCS with the C6 series and the with the high resolution. And also then you can double the speed. Another application from our partner AKU in Germany. There was a 300 degrees inspection of powertrain parts. So unfortunately, we are not allowed to show the parts of the customer. So there's a reference part below of the sensors. What we are doing here, we are using 3 modular compact sensors as a dual head because there are really complex parts and you have problems with shadowing and occlusions. And with the AKU, with the vision manager of AKU, it's a framework around where you can use different third-party libraries. You can make easy multi-sensor calibration, and then you get a 1-point cloud, as you can see here, out of 6 sensors. And you also can do quite simple new jobs for new parts. And in combination with our sensors, you really get a really robust application. So as a summary, you see what we have, and you will get the best sensor with the highest speed, with the highest resolution in the market. And I guess you will have a right sensor for the application for you. And so we can replace a lot of sensors, but nobody can replace AT. So this was maybe the summary. Thank you for listening. And now, do you have some questions?
It seems so.
So it was fast. I speed up, but I talked about warp speed, so I guess it fits there.
Okay. Is the point cloud data accessible via C++ interface so I can implement my own detectors?
Don't exactly know what I mean, but we are transferring the data to the PC. Means you can handle the point cloud, whatever you want with C++, C#, and so on. We are providing the image, and the rest you can use your own vision tools, or you can use third-party libraries. There we have a lot of examples which you can use to get the point clouds quite easy in your software.
Mm-hmm. We're going back to the question before. Can your sensor measure the straightness of plants, Sturm? Since in this case, the material is not metal.
What is the application? So my suggestion is to send us an email with more specifications, maybe also some pictures. And as I showed here with our MCS configurator, we quite simple can put all specifications in the configurator, and then there will coming out a nice sensor, and then we can talk about it.
Tim, Patrick, and Armin, it would be great if you could write your email addresses at the chat so everyone is able to get in contact with you. At the moment, I see. Okay, next question. Is there an interface for
my slide here? You see, the best one will be sales@automationdechnology.de. No? Yes. So
something like this, so people are able to get in contact with you. Is there an interface for MVTech? I think for Halcon probably, or Merlik.
Maybe not an interface, but we have a lot of examples which are installed automatically with our support package. You can use these examples and then starting to develop your application on that. So it's quite simple to get the data in for MVTech, for Halcon, yes.
You mentioned the new C6 series. Which sensors are available at the moment and which will be coming next?
So you saw, we talked about this modular compact sensor. There is a C6 with the Imager 4090 HS is still available. Then next will come the cameras with a separate laser, and then step by step the compact sensors. As I mentioned, we have 50 different sensors. It will not come all at the same time. So, but depends on the priority and so on. But with the MCS, we can do a lot of that. And the new 4070 sensor will be available in the second half of this year.
So thanks. Looking at the clock, 20 minutes are over. So we go on with our next presentation. Thanks, Armin.